Hello college algebra student, this video is for chapter 5.1 part 4, the second part of application. So I'll do two more applications. So first is about selling tickets, selling something, and we want to find what is the maximum revenue. What happened is there's a stadium. They are selling ticket at $11 and the attendance was 27,000. But if they drop $1 to $10, the average attendance rise to 32,000. And then we assume that the attendance is linearly related to ticket price. So that means you drop a certain a dollar, it would rise certain number of attendance. So first is just the old stuff. Write attendance as a linear function of price. So to write linear function, we need 2 points and then find rate, right? So what are the 2 points? So price, attendance is y as a function of price p is x, is x. So when it is price is $11, then it's 27,000 attendance. So this is x1 y1, just like in chapter 4. And then when it is $10, then it's 32,000, right? This is y. Attendance is y. So it's y2, x2. So we can find rate. This is linear function first. Rate is 32,000 minus 27,000 over 10 minus 11. So that would be negative 5,000. So you drop $1, or you drop $1, you increase 5,000. That means if you increase $1, it would. If you decrease, it would increase. If you increase $1, it would decrease 5,000. So what's the linear function then? So we'll just do the Ponslow form. Y minus y1 equal to m x minus x1. So after you multiply everything, so that would be negative 5,000. Well, our x is actually p, price. X plus 55,000, right? 27,000. So y is negative 5,000. X plus 55,000 plus 27,000 is 82, right? 82,000. So you can say y is, so you can rewrite it as negative 5,000 p plus 82,000. So this is the attendance y. So write revenue as a function of price. So revenue is how much would you earn? Revenue is how many people attend, right? Attendance. How many people pay per ticket, right? Y times P. Y is Y. Oh, Y is actually that. So you plug it in. Negative 5,000 P. So that's why we need that. Plus 82,000. And then times one more P. So it's not. This is that one, right? From here. So R is equal to negative 5,000 P squared. Now we have a quadratic function that disappear. That comes out. This is a multiply. Y times P. So this is a quadratic. So we can write it. Now we are going into the C part. We want to maximize revenue. So to maximize this, we have negative B over 2A, right? Maximum, it happens in HK and Vertex. Vertex is negative B over 2A and then F of negative B over 2A. This is the price. This is the revenue. So the price would be just negative B over 2A, negative, what was it? B is 5,000. over 2a. Oh no, I have to look at it. This is at the end. Because, yeah, negative b is 82. Negative 82,000. A is negative 5,000. So, negative 82,000. Negative b, right, over 2a, that would be negative 10,000. So that would be 8.2. So if you charge 8.2, that means you actually decrease the price. You would actually maximize your revenue because more people is going to come in. Okay. So this is the price. If you want to find out what the actually revenue is, would be plug it in, right? So plug it in to f of 8.2. And I put it in, it is equal to, where did I calculate? 336,200. So you would gain that dollar. So that is the first part. The second one is actually two more. The second one or the third one is actually use decimal to find maximum. So they give you a function which is temperature of a person that has fallen into illness. So a person fell ill, and then you probably had a fever or something. So this temperature function actually show what the temperature is, which lasts for 24 hours. And we want to find out what is the maximum temperature given by this function. And we can actually do negative b over 2a, right? Because we are talking about maximum, not solving quadratic formula. We are not solving for 0. So maximum is just negative b 2a, so it's not too bad, but we'll try to use decimal to find it. So write down the function is negative 0.01 t squared plus 0.214 t plus 98.7. So calculator can actually help you. So let's try this. Y equal to, or we can say t equal to, we can just do y equal to negative 0.01 t squared. You can do t squared plus 0.214 t plus 98.7. So now our we probably need to change our settings. You click on setting. Our y is too big. Our y probably is from 0 to 110 because it's degree. Oh, we find it. So you click on the highest number, so that is the highest. You click on the vertex point 10.7, that's the hour, and the maximum temperature is 99.845. Just click on, that's the highest point. So using the decimal is very easy. You don't have to do it. Okay. So time is after 10.7 hour. The highest temperature is 99.845 degree Fahrenheit. So that's very easy. Use decimal. The most important thing is to set the settings so your Y is not like in the 1,000 or just 10 unit, or you can zoom in. Example 4 is a very common question. They say you have some fence, the fence length is 84 feet, and you want to make a rectangle using this fence. So you can use whatever length and width you want, but it has to, it's a little crooked. It has to have a total perimeter of 84 feet. So let's say width and length. So, and we want to maximize area. So what is area? Area is length times width. But this is not a quadratic formula, quadratic, equation. So, and there's two variable. I need to replace it. So there's one variable. So how can I do that? So I would write a relationship between L and W. What is the relationship? The fence length. Fence length is parameter. So that means 84 is equal to 2W plus 2L. Divide everything by 2. 42 is L plus W. Right? So I can say L is 42 minus W. If I minus W on both sides. So I'm going to use this to replace it here. So to force it to one variable. Whenever I see L, I do 42 minus W times L. Now I have a function that has a 42W minus W squared. That is a quadratic, right? It's a W squared. And then this is A and this is B, right? Because negative X squared, you can rewrite it as negative W squared plus 42W. How do I maximize it? I want to find the vertex. Negative B over 2A, negative B over 2A, negative 2. So that is 21. So when W is 21. So W is 21 is the vertex. Whenever they want maximizing, you want vertex. Don't solve for 0. Solve for the negative B over 2A. So that will give me maximum area. So what is the length then? The length is here. Length is 42 minus 21, also 21. Okay, so what's the area? Area would be 21 times 21. Length times width equal to 21 square. Clear 21 square. 441 feet square. So this is the largest I can do with 84 feet. And the dimension is, so this is the maximum area when the length and the width are 21. So that's all the work problem we have for 5.1.